Hello, good morning, good afternoon, good evening, whatever time zone you are, welcome to the Bay Area Apache Spark meetup. We're coming live to you from three different platforms, X, YouTube, and LinkedIn. So wherever you're from, drop in a line to say you are hailing from different parts of the world. And I have to shut down this thing over here. And so, whatever time zone you are, just pop in and say hello. We would like to find out where you're actually hailing from. My name is 𝗔𝗽𝗰𝗵𝗲. I'm part of the developer relations team over here. And joining me is 𝗟𝗽𝗰𝗵𝗲 from LanceDB. Jack, you want to say hello to the community?
Hi everyone, I'm Jack.
Thank you for being here. And in the background, we actually have 𝗟RHI, who is our esteemed program manager, and she's doing all the magic to get us live. So wherever you are from, please drop in a line to say hello. Just to get started, before we do that, I just have a couple of upcoming announcements that I want to share with the community. So we have a few upcoming events. One is on October 7th, we actually have a webinar dealing with how to actually have your agents remain in the Lakehouse agentic future. So if you're interested to find out how you can actually use AI agents for your Lakehouse, do join in that particular webinar. There's a link there to register yourself. And then for those of you who are in the Bay Area, we actually have an open Lakehouse mini summit in Mountain View. This is going to be in person, half a day summit. And we're going to conclude that with Apache Spark Happy Hour, where we'll be sort of sharing with the community what are some of the things which are actually coming up with 4.1 release. And we also have a couple of presentations in the summit about Spark. So if you're living in the Bay Area, this is a good opportunity to come and meet us in person. And then finally, on November the 27th, we have an open Lakehouse meetup in Paris. So if you are in Europe and if you are living in any of those countries, you can just take the metro, you can just take the train, you can just fly in and attend that particular meetup. The other upcoming event that I want to mention, if I can get my mouse over here, is the next Spark meetup is going to be about a month from today, and we're going to have people from NVIDIA talking about Spark Connect, how the NVIDIA accelerators kind of allow you to accelerate your queries with Spark SQL and MLlib. So if you're interested to find out how you can actually use Spark Connect, which is really expanding its ecosystem with the community and with the contributors and users. So come and join us on October the 27th, 9:30 a.m. This is going to be a virtual meetup. To hope to see you there. Having said that, I think I'm ready to hand it over to 𝗟𝗽𝗰𝗵𝗲, who is going to be sharing with us about today's topic, how Spark Connect and LanceDB work together. Not Spark Connect, but Spark Connector works with the LanceDB. So he'll tell us all about that. Jack, it's all yours. Take it easy and then enlighten us all about the Spark Connector for Lance.
Sounds good. Yeah, as what we just said, the topic today is going to be scalable multimodal AI data processing with the Apache Spark connector for Lance. So this is the good old Spark connector, not the Spark Connect. Yes. So before we dive in a little bit about me, I have been working in data infra domain for quite some time. Currently a Apache Spark PMC member, also Apache Polaris PPMC member, a maintainer for the Lance project, also contributor to a few different open source projects like Spark and Trino. Before joining LanceDB, I was in Amazon for 7 years, was a tech lead for integrating open table formats like Iceberg Delta into EMR and Athena. Later was one of the main architects for the SageMaker Lakehouse and S3 tables. So I think multimodal AI is a very hot topic today. Like every single company, every single AI startup is trying to slap the multimodal AI label into their products. But here we are talking about the actual thing, the real deal. And the Lance is what we want to make it the standard for the multimodal AI format. And I'd like to first talk about what is Lance and more importantly, why another format. So when we look into the challenge of using multimodal data like images, videos, vectors, embeddings, all these kind of things for AI training and AI applications, comparing to the traditional data lakehouse, data warehouse situation, The challenge is that the multimodal data is much bigger than the tabular data. So traditional tabular data is like 145 bytes per row, pretty common. And when we add embeddings, which is vectors, a list of floating points data, that is roughly 4 KB per row, which is 25 times larger than normal. And when you add images, videos, the whole row just explodes, and your whole data set explodes in size. In the past, when we see like terabyte level data tables or petabyte data tables, that is already huge. And this is like normal situation when we work with different frontier labs, different AI companies. So that really, I think we deserve some new solutions that can fit this scale of the data. And when we imagine what we call the frictionless AI infrastructure, today we have the data lakehouse that can serve most of the analytic workflows and have a very open architecture. However, when it comes to the AI applications, you still have to do this kind of data silo situation, which is, for example, if you want to do a full text search, you have to load your data into Elasticsearch to do that. If you want to do vector search, you have to look into all the variety of vector databases and then load it into that. And then maybe you have to use Postgres or different engines to do different purpose-built applications. So you are still creating these data silos. If you look into this diagram, what I'm showing here, you might feel familiar because this is exactly the same situation when we are trying to move from a closed data warehouse system into an open lakehouse system, so that different engines can plug into the same storage layer to do different kind of analytic workflows. And here, when we say we want to do a multimodal lakehouse solution, this is kind of doing that for the AI situation, that we want to not just have Spark, Ray, all these compute engines to use the same solution, same storage layer, but also search, vector search, full text search, all these kind of thing, from training to serving, everything using the same open format under the hood as the backend infrastructure. So to make it more concrete, what we really envision is that you have your tabular data, which is your traditional information that you are storing in the tabular sense. You can also have full text, very big full text, generated from large language models, generated from different caption services, as just different columns, and you can run full text search against the same table. And you can also have vector data that are just different columns that are storing all these very large vectors every single row, and then you can run vector search against that. So a single source, different retrievals, that's what we are envisioning. And Lance is really what we have built to enable that, the single source of truth for multimodal AI data. So when we say Lance, it's actually two things. There's a file format, which is a columnar format for fast scan. And there's a table format which offers very AI-centric features like two-dimensional storage, zero-copy data evolution, and all these kind of lists of things. I'm not going to go into details in this presentation because this is a presentation for Spark integration with Lance, but just to give you a sense of that. And today it is already powering lots of the multimodal AI applications. We have a very good range of different companies using this in production today, ranging from normal companies' internal AI data infrastructure to the data infrastructure vendors to different frontier model AI companies to different AI research institutes. These are all using Lance today to power their multimodal data. So just to dive deeper into what the different components in Lance is optimizing the multimodal AI workflow. So first of all, we have this Lance file format component. And the most important goal of the file format is really to enable fast random access. Because if you are coming from a analytics background, there are formats like Parquet, Avro, Awk. Those are very optimized for OLAP situations. However, when it comes to random access, which is probably one of the most important access patterns for AI applications, for doing search, for doing shuffling training, all those kind of applications require random access. And what we have achieved is that you can do only a single IOP when this is a fixed size field, such as a vector, and you can do only a 2 IOPs random access for any variable length things. And it supports compression, supports different encodings, just like any other columnar file format. And one of the biggest innovations we have done in Lance is we have removed row groups, because that is really not working well with multimodal data on the object storage today. When we have multimodal data, it will range from just a boarding, which is 1 byte, to videos, which is gigabyte of sizes. And when you have row group really becomes a constraining factor for how you store data, because if you tune the row group to be too big, then it has problem for writes. And if you turn the row group for too small, then it has problem for read. You can really become really hard to achieve a balance. So we just really just remove that, and that becomes really a very key factor for improving the performance and how and as you can see, this is an example of how a Lance file will look like. There is still the footer, just like 𝗏𝗏, and which points to the column metadata, and the column metadata directly points to data pages. And you can have a lot more data pages for different for the larger data, and a smaller number of pages for the smaller data columns, and they don't have to align with each other. And how we do align is really a separate thing in the table format that I will talk about afterwards. And this is our lovely Western Pace, who is doing the talk in the VLDB conference just last month. And we actually published a paper about that. In addition to the row group, we have removed row group. We have kind of added this pluggable structure encoding feature also into Lance format. And for example, when you are storing the blob data, such as image and videos, you no longer have to store that in a separate, for example, a separate S3 bucket, and then you have a file location pointing to that bucket. Instead, what you can really do is that what we call storing that as a blob encoding in Lance, so that the data are actually stored not within the page. So when you see the page here in the file format, those are only storing actually the blob metadata, such as the location of the position of the file and the size of the blob, all those kind of metadata information. And the blobs are stored within the same file, but they are stored out of line, so that you can have a blob encoding. You have a blob API used to directly access those blobs, and this can really accelerate applications. For example, you have a GPU, and instead of you have to do lots of IOs to pull data from object storage, you just pull a single file in Lance, and then you can access all the different files using different positions in the file. And then going into the Lance table format, that is really one level above the file format in order to make the multimodal AI experience much better. So we have different fragments similar to, for example, iceberg and delta format. Those are data files that representing a section of the data in the storage. And then we have in every single fragment, what is unique in Lance is that data columns, different files in different data columns, different data columns can be stored in different files. For example, in this example, we have one file storing data for only column 1, and several files storing data for column 2 and 3, right? So they can be separated instead of combined in a single file like 𝗏𝗏. And another unique feature is that index is a first-class citizen for the Lance table format. So you can build different kind of indexes, both the scalar index and the vector index, in order to accelerate different queries. And for the indexes, those are just another set of files that are stored in object storage and retrieved to accelerate your queries. And we especially for people who are using Lance for their vector workloads, we have like basically most of, actually I should say probably all the well-known vector index algorithms and built into the format, such as PQ, SQ, RabbitQ, SP-Flash, HNSW, all these kind of things are in the index as a format. And what is unique also with Lance is that we have a concept called row address. A row address is a combination of the fragment ID, which is 32-bit integer, and the position of the row in the fragment, which is another 32-bit integer. So together they form a row address, and the indexes are really you can imagine it's a map of mapping some values into some row address in some way. And once we know the row address, we can go into the Lance file and do that do the random access very quickly. And going back to what I was saying about we are storing different columns in different files. That is really to oriented for the feature engineering use case, what we call data evolution. So for traditional table formats like 𝗟𝗿𝗿𝗲, you can do schema evolution, which means you update the schema and all your new data coming to the table can use a new schema, and the query still works. However, that imposes a big problem for the machine learning users, because usually if you add a column, that means that's a new feature and you have to backfill for the entire table. And if you do that with 𝗟𝗿𝗿𝗲, then you have to rewrite the entire table every time you add a new column. And for Lance, you actually don't have to do that, because you just add a new file, and that represents the new data in the new column, and that's it. So that becomes a very efficient feature. For example, this is an example for using that with Runway, which is one of our customers that is doing video large language models, video frontier models. And here you can see that they started with a table with just the video data. And then every single rectangular box you can see is different kind of columns they added using the data evolution feature. And all the diamond boxes you can see are either some simple UDFs or some kind of process running GPU using larger language models to generate captions, generate vector embeddings, all those kind of things. And you can just keep appending columns after columns, and you have a very wide table with all your features, and those can be used for serving, for analytics, for different purposes in downstreams. And just a side note before I enter into the Spark connection with Lance, many people have confusion about the Lance format and the LanceDB, because LanceDB is also open source project, and Lance is its own open source project. So the hierarchy is the following. So Lance format defines the standard for how you store multimodal data. And within the Lance project itself, there are different SDKs. Those provide search, query, write, maintenance, all these different capabilities on top of the format. So it's kind of like implementation of the format with different features. And everything is implemented in Rust. And there are bindings in Python and Java that are core into the Rust core for high performance. And the LanceDB is another layer on top of the Lance SDKs. So it offers, the main goal is to offer a developer-friendly embedded hybrid search engine. When I say embedded, that means it runs in a single machine, kind of like DuckDB, if you're familiar with that. And the focus is on all the AI use cases, algorithms, and integration. So if you go to the LanceDB open source, all you see are all those like re-ranking algorithms, and also integration with like Llama Index, LangChain, all these kind of very AI-centric applications. And if you are a developer for engines like Spark, you probably look into the Lance SDKs for integration. And then there's LanceDB, kind of overloaded term for Cloud Enterprise, which is the company that is offering distributed engine and those kind of stuff. And now we can actually go into how you can use Spark with Lance to load your multimodal data into your Lance Lakehouse, and also use Spark to do some query processing, all those kind of good things. The main use cases we see are kind of the 4 use cases. The first one, which is the primary one that currently we see most of our customers are using Spark for, is you want to do large-scale ETL and dump data into your Lance data lake. And Spark is really good at that as an ETL engine. And also, Spark supports update, merge, and delete at row level. So people also use that to do data modifications and optimizations on top of the Lance data, because Lance is a transactional table format, so all these kind of operations are supported. And typically, people don't use Spark a lot for doing the AI-centric things, because, for example, they just use PyTorch for training, they use LanceDB for vector serving, all those kind of things. But it always becomes handy because Lance allows you to store tabular data together with your multimodal data. And usually you want some kind of analytic SQL operations to be done on top of the Lance table as well. And that is when the Spark SQL comes into play, and you can run whatever SQL against whatever Spark SQL against the Lance tables. And one situation we see very common is that when people have very large joins, like you are joining like 5 tables in a single query, and you are doing very big aggregations which triggers big shuffles, that is when Spark is kind of the go-to engine today. because comparing to you do embedded engine that will require very high requirement for the hardware, you can still use very cheap software hardware, and you have a distributed engine like Spark to do the joins. And going back to the example I was showing before, so like how the initial video column is loaded, that is usually coming from Spark. And for people who are kind of migrating from a closed system, like a closed vector DB system into an open vector lakehouse system, they usually have some kind of vectors that are stored, and they are also loading the vectors into their new lens tables in using Spark. That is what we typically see, and you can do the queries using Spark as well. And going to how some details about how you actually use that. The installation is the first part. So today, the LanceSpark connector supports Spark 3.4 to 4.0 officially. I heard people in the community also using that for 3.3 and even lower versions. But the official ones are 3.4 to 4.0. And we support all the Scala versions and all the Java versions corresponding to the Spark engines. For example, if you are using 4.0, then you can only use Java 17. But if you are using lower versions, then you can use lower Java versions as well. And we published 3 different kinds of jars that you can use for the Lens connector. There is a base jar, which typically is only recommended if you have your own internal Spark versions and you want to have like a native integration of that. And there's a link jar if you are building a Spark application and you are managing your dependencies independently, then you can use a link jar. And if you are directly starting a Spark session and want to use the Spark connector, that is when you can use the bundle jar, which comes with all the dependencies bundled, so that you don't have to figure out all the dependency madness yourself. And everything is published into Maven Central for consumption. When it comes to configuration, probably the most important thing is how it integrates with Spark catalog ecosystem, because our implementation is using the latest Spark connector data source v2. So that essentially every time you connect to a Lens connector, you create a new Spark catalog, and then you query the Lens tables within the Spark catalog. So what we did recently is we created a new sub-project called Lens namespace, which is really used to standardize all the lakehouse connections. So on the left side, you have different catalogs, metastores, meta lakes, whatever name that is. Everything in Lens is a namespace. So we have a Unity namespace, you have a Hive namespace, we have a Gravity namespace, all those kind of things. And on the engine side, for example, in Spark, then the Spark connects direct to the Lens namespace interface, which in turn connects to all these systems, so that you can store your Lens tables in all these metadata services in all these catalogs, and the Spark can connect to those through the Lens namespace interface. Here are some examples. For example, if you're just getting started, the de facto is we recommend you just use a directory namespace, which is just a directory in your local storage or in cloud storage. And the directory contains a list of tables. And for example, if you're using Unity catalog, then you can connect to Unity using this kind of syntax. You just point to your Unity URI and say the implementation of namespace is Unity. And similar to, if you're familiar with Iceberg, there's Iceberg REST catalog. In here, we have Lens REST namespace. So you just specify the REST as implementation. You can do whatever endpoint you are using, either self-hosted or LanceDB provides you an endpoint as well. And now going deeper into the operations, this is kind of the most important part about how you can use Lens with Spark. So in general, most of the Spark DDLs, DMLs, and query languages are supported. And I like to highlight a few use cases, especially with multimodal AI data. And the first most important thing is, of course, you want to create a table. And in Lens, the unique thing is that Spark today doesn't really have this notation about the vector types or those kind of things. That is something we want to add, but today there's this workaround that, for example, here there are these 2 vector columns for text embeddings and image embeddings. One is a float array and one is a double array. And what is unique about vector is that as long as, because all the vectors are of the same size, and a fixed size vector is much more performant when doing random access. in Lance. So you can specify actually that my vector is, in this case, like 384 size array, or like 512 size array. And when and we are using this fixed size information, this information will be stored in the Lance table behind the scene, and that is going to accelerate the query. Another thing I didn't mention here is that if you want to, for example, create a column for image videos, you can just create that as a binary column, and Lance will take care of using that as a blob column. And once you create a table, you can directly start to read it, just like how you can use Python, Scala, Java, or Spark SQL to read the data. Here, this is an example using Python. So you do Spark.table, whatever table name that is, and you can do filters and select. If you're coming from the data lake world, you probably know there are optimizations like predict pushdown, column projections you can do. All those kind of things are supported in Lance, of course. However, the implementation of that is actually a bit different from how usually it is supported with other formats. So what really happens is that because we are there's a Lance SDK that is very optimized in Rust, and also we have all these indexes that can use to accelerate the query further. What we do is that in the Spark driver, when you have a query, we distribute all the fragments in different executors. And in the executor, what happens is that there's a Lance scanner in the Lance Java SDK, and the Java SDK calls into the Rust code behind the scene to run the native code. And the native code, what happens is that the scanner will say that I'm scanning this fragment, and I have all these indexes I can consult. And also I have maybe some filters like age greater than 25, name, and select is name and email. So I only need to select 2 columns. So based on this information, it will use the indexes to prune, do the predicate pushdown, and also all those kind of things. So for example, if you have a B-tree index, then you can actually prune 2 exact rows that you have to scan and then do the random access of the rows. If you have an inexact index, such as a zoom map index, which is similar to the min-max stack in Parquet, then you are doing an inexact scan, and then the scan goes into the actual arrow reader to read the data out. And once the arrow reader is reading the data, Spark already has support for integrating with arrow and doing the vectorized read into a columnar batch. So the integration actually goes very smooth. Just Lance gives you the arrow batches, and then that translates into the Spark vectorized column batch to be read back. So the whole system is very efficient in that sense. As I said, the primary use case for the Lance Spark Connect today is to ingest data and do data modifications. So here, this is an example of God using that to do the insert. So you can do insert into that also has corresponding Python data frame operations to do the data frame.write. We also have update and delete, so that you can update data and delete data in the Lance table. What is worth talking about is that in Lance, all the operations are merge on read. So typically we don't recommend people to do copy on write, because Lance is actually very oriented and designed to be optimized for merge on read operations comparing to other table formats. That has a lot to do with what I was talking about, the row address concept previously. Because a row address is a combination of the fragment ID and the position of the row inside the fragment, that naturally gives us a very good combination of the distribution key and sort key to plug into the Spark execution plan. And when you plug into the plan, or what we have here, a deletion file. Deletion file is a bitmap, and the bitmap only works with int32 in most cases. So the bitmap actually works directly with the row address to say that in this fragment, a specific position has been deleted. And that allows us to very efficiently do merge on read comparing to the other table formats. And also, because we are kind of standing on the shoulder of the previous implementers, the previous implementers such as Iceberg Delta already hashed out how the how the row-level operation should look like. So today in the latest Spark versions, all these interface are already there. So it made it pretty easy for Lance to just plug in and implement the merge on read operations, and it just works. Yeah, and those are the main operations that we typically see people use for the Lance Spark connector. And I'd like to talk a bit more about upcoming features because this is actually a very actively developed connector. There are lots of companies that are contributing to this right now. One of the biggest feature that is almost being merged, I also wanted to add that into the previous slides, but we are still doing some vetting, is the data evolution feature. So you can actually do alter table, add column, add select, which is kind of cool. So that you can have a data frame, and then you can append that as a new column directly into a table. And if you don't have data frame, you can also just specify use a different function in Spark, and that can compute the actual column value at the runtime and backfill your whole table very efficiently. And another hot topic that people are currently developing is the vector and full text search extensions for Spark, so that you can do user-defined table functions to do full text search and vector search. We can also have PG vector like vector search syntax, like the bracket to being like similarity search using a Spark SQL, those kind of things. And distributed index building to distributedly build a vector search index using Spark. There are also other DDL extensions such as branching, tagging, shallow clone. These are also available in Lance, and we want to expose that into Spark. And as I said in the create table slide, today Spark don't have these multimodal data types such as a double vector, a vector, a half vector, and also for blob types, we kind of do some checks internally to infer if you are using a blob type. So we want to expose these types also as Spark user-defined types into Spark directly, and make that you can directly write a Spark SQL like create table with a column type as a vector, so that the whole ecosystem is coherent in that sense. There are, of course, also things like optimize and vacuum, where I think people have interested to expose. This kind of thing actually pretty easy, actually, comparing to the other formats to expose, because all the core implementations are already done in Rust in a very performant sense. And what we are really doing here is to take the glue layer, so that Spark is able to call those layers behind the scene, so that Spark users can directly leverage those features. On the performance side, one of the things we're actually working on is the task distribution with zones. So going back to the read slide, today what we do is that in the driver sense, we directly distribute all the fragments into executors, and the executor does the predicate pushdown. This is a bit inefficient in the sense that some of the fragments ends up with a no op, and the executor is just doing redundant work. So what we want to do is we want to do a coarse-grained filtering in the driver for the fragments, so that we just don't even stand the fragment if we want. And also fragments can have different sizes. So we have developed this concept called a zone. So instead of distributing fragments, instead we distribute the zones to be more fine-grained. And there are also people exploring doing integration with Data Fusion Comet and Velox for the vectorized engines integrations. And also we have log structure merge read, log structure merge write that can be integrated with Spark streaming. So lots of exciting upcoming features that are going on in the Spark connector. Yeah, and in the end, I like to have this dedicated slide to thank all the community contributions. What is kind of crazy is that as someone work directly for LanceDB and have a direct tie to improve Lance, we actually don't spend that much energy into the Spark connector, because we have LanceDB, which is its own engine to do its own things. And the Spark connector is actually a completely community-driven project from the start to the end. Like the initial code is contributed by ByteDance, and then all these companies have contributed along the way for different features. And we are just seeing more and more momentum for people to join the group and add features. So this is very exciting. As an open source engineer, it is always very appreciated to see this kind of movement in the community. Yeah, and last, if you're interested, these are the GitHub links. There are docs about Spark connector. There are all the SQLs you can check how you can run that, and there are blogs about Spark also on our website. And there's a Discord you can join to discuss with us about all these features. Thank you.
Well, thank you very much, Jack, for that wonderful, comprehensive, and technical introduction to both LanceDB as a format and how people who actually are interested to do multimodal AI ETL using Spark connector with LanceDB. A few questions that actually have come up. Let me start one with somebody from LinkedIn user who says users who are already on Iceberg Lakehouse will have some inertia when it comes to adopting to new file and table format. What are the tools and mechanisms available to help them make that particular migration?
Yeah, that's a good point. I think today, sounds like the question is twofold. First of all, like there's this competition of Iceberg Delta versus Lance. I think the competition today we don't see much less competition, but more, I think, complementary situations, because Lance is. If you look into all the features on the website, all those kind of things, it's mainly oriented for AI ML use cases. Comparing to Iceberg and Delta, these are very much oriented for BI analytic use cases. So when we talk to, for example, Netflix, Uber, those are actually working on Lens today. They see this as very complementary to each other. But of course, on the other side, if you are coming from a fresh company like all these AI frontier model companies, they don't have much existing infrastructure with these existing open table formats. And it becomes very attractive for them to say that, oh, okay, I already have Lens, and I already have this tablet data as well. I might just use that also for my analytics workloads. So from that perspective, that's a little bit competing, but I think we are not to that stage yet. Yeah, and from the migration tools perspective, what is good is that Lens, as you know, is both a file format and a table format. That means it doesn't really exist a situation that you have existing Lens files you want to migrate, because if you are in existing like Hive tables, Hive tables, Iceberg tables, Delta tables, Foodie tables, you are in Parquet files, and you certainly have to do a whole data dump into the Lens lake to make that work. However, what we see people have been doing is that they usually keep, as I said, a complementary Iceberg table for their tablet data, and they start to have the initial embeddings loaded into Lens, and then you keep adding different columns in Lens tables. So you have this kind of a two-table situation going on for a while until you decide if you want to keep doing that or you want to do a whole migration.
Yeah, just to add to something that I want to make sure that we clarify that there's no longer a competition between Iceberg and Delta. The community is actually converging and coming together, and I think pretty soon they'll be very much interoperable. So I don't think we actually will have an issue where you have to keep separate silos for one or the other. You should be able to, through the compute engine, access one or the other, whichever format you wanted. Another question that actually came is from another LinkedIn users. Users who are already, no, it's not there. Great talk. Thanks, Jack. Great talk. I admit that. Brilliant. Another question for someone interested in contributing to Lance and LanceDB in open source. What are the areas or tasks that are good places to get started, right? I guess you mentioned some of the ideas for Spark connector. What about Lance and LanceDB itself? So the two questions, one is how do I actually get started, or what are the best places to start contributing, and both in the Spark connector realms, but also with Lance and LanceDB.
Yeah, I think first of all, what I usually recommend people who are interested to open source contribution is that you should do whatever interest and you think is the most important, either for your personal interest, also for, or you are working for a company, then for the company interest. And that will give you a direction about which exact domain you want to focus on. For example, in the side note slide, I was talking about most of the AI features, like all the algorithms, all the AI integrations are happening in the LanceDB side. So that might be a good open source project to do those integrations. And for Lance, this is very much format features. If you are very into the table format, file format realm of things, there are lots of different features that are good to be looking into. And for the Lance community, what we usually discuss these are in the GitHub discussions. So all the new features, you can actually check out all the proposals in the GitHub discussions of the corresponding GitHub repos. And if you have a need to use Spark, or if you have a need to use other engines like Ray, then there are all these sub projects like LanceSpark, LanceRay. You can check out. There's also LanceTrino, LanceFlink, LanceDuckDB, all these kind of sub projects that people are contributing to do like engine specific integrations with Lance. And if you have a catalog you want to integrate with, then Lance namespace is a project to go. Yeah.
Yeah, I mean, as you say, the ecosystem is actually growing. So depending on where your needs are and where you want to get contributed, and if you're the first time contributor, I think one of the things that I've noticed in the open source community, people actually are eager and want to get started is what they call the easy fix or the first time needs, or we need the help from the community. Some of the issues are normally tagged as first time or new contributor, so that's actually a good way to get familiar with the code base itself. We have a question from Kristen Neil Nuremberg from LinkedIn. He said, do you need a catalog to use Lance? I think that's a good question. If I was using that, say, on my open source platform, I mean, on my laptop, do I actually need Iceberg to be installed? Which data catalogs have support for Lance format? And I would add to that particular questions, if I was using Lance along with the Spark connector on my local laptop, most probably I'm going to be using Spark Warehouse. So how does that work? So there are two parts of this question. The first question is, which catalogs do I need minimally in order to run that on my laptop? And if I was running on my laptop and I don't have Iceberg installed, what other catalog does it actually support? Can I use the local Hive Metastore default that Spark uses?
Yeah, so Lance is from a table format perspective, it is a storage-only format. So you don't need a catalog to use Lance at all. And all the transaction semantics, all those kind of things are embedded with storage only. That's a big tenant for Lance. So you can definitely start using Lance just on your laptop with your local disk. That definitely works. On the Spark side, I think I showed a slide about what we call a directory namespace. That's essentially a storage-only solution that you can just use that to get started. And it just stores a Lance table in a directory. That's it. For the catalog supported, I think the list is expanding very rapidly. So if you go to the Lance web documentation website, you obviously see the full list. And today, I think it's just, of course, Hive Metastore, a Unity catalog. And I think people use Gravitino through the Hive Metastore. And there is an ongoing integration with Polaris. And there is integration with Glue Data Catalog. I think, yeah, and there is a REST catalog. Those are the current options.
Yeah. Some question I was actually curious. Initially, you actually mentioned something about row groups. Guy wearing a T-shirt. Having row groups is committing blasphemy. For users who are not familiar with the idea behind row groups in Spark, could you tell what row groups are and why it's a bad idea to use row groups in this particular case with LanceDB, just for the edification of some users who might not be familiar with the concept of row groups?
I see, and I won't say it's bad. It's a brilliant idea, and it has been working very well for a very long time. I think what really happens is that two things. First of all, the stack has been modernized. The row group concept is a concept created in projects like Parquet, Avril, and that was the era of HDFS, Hadoop Distributed File Systems, and there are when you have row groups, you have alignments, and that works very well with the Hadoop block sizes, or those kind of things. However, today we have object storage, and at the file level, we already have the we can already do massively parallel reads across different files, and that makes the row group concept a little bit redundant from that sense. That is one thing, just from a general perspective. So this is just one bit of modernization as we move to a more cloud-centric environment. And on the other side, I think what I showed here, let me go back to that slide, which is probably going to be more clear, that when you are storing multimodal data, that is when the problem of row groups comes in, because the row groups is defining a constraint on the size of the total number of rows that you can store within certain bytes. And that doesn't work well when you are storing some rows with very small data, and some rows with some columns very, very small data size, and some columns with very big size. And once we remove that constraint and move that as a table and the object storage layer, then this problem doesn't exist anymore. So that is what we think the innovation is at.
Good, brilliant. Question from LinkedIn from Lens or Sens. How could we do the vector query using Spark? Or we need to write a UDF with Lens to do that? In other words, if I actually wanted to make a query, how do I actually do that? I think you had a slide in there that actually shows both from PySpark and Scala, but maybe you can explain a little more in detail. If I wanted to do a vector query with Spark, how do I do that?
The vector query is still work in progress.
I think what he means by vector query, I believe he probably means how do I actually do a search. So yeah, go ahead.
Yeah. So you can, of course, just select the vector column, and it will return you the vector data. And for the search feature, I think I'm listing that as a work in progress. So there are two experiences where I kind of I won't say debating, but people have different use cases for different ones. One use case is you can define a use-defined table function, so that the table function will project. It's kind of like a view, but like a deterministic view. You can apply to a table to say that this is a vector searched view of the table, and then you can select the result from that, and that under the hood performs the search. Or there's like the PG vector-ish experience that you can like the SQL syntax directly represents a search. So both of that is work in progress right now, but not usable yet. Yeah.
So when you say work in progress, are we talking about coming up in the upcoming release?
That
needs to be determined. Okay.
Community, you can never guarantee a date for whatever.
That's right. So I was curious, how does the connector, when it's actually in your slide that you actually say spark.read table, the table is actually in Lance format. Underneath, is it actually using the Python data source format to be able to convert that into data frames? Because I know there is an integration that you guys wrote as an extension to Py data source API.
Oh, I see. Yeah.
Or is that something completely different?
Yeah, that's actually a different integration. So this is directly a native integration with the Spark data source v2 APIs. So everything is going through like Scala, all those
yes.
things.
So this particular, when you say
offers more features,
right.
And the Python one is like for people who just want a quick implementation and quickly loading data through Python without any touching of the Java dependencies, then that is the way to go. Yeah.
Okay, so if I actually wanted to use I would include that in a Spark session, all the .jars files in my PySpark session, correct?
Correct. Yes.
Okay. Now all this Spark connector, is that also available through PyPy? Can I actually do PyPy install of that Spark connector, and that I don't have to specify something in a Spark session, or you are not there?
Yeah, both are available. Yeah.
Both are available. So if I just do PyPark install Spark connector LanceDB, and in my Spark session, I don't need to provide jar files; those will be automatically loaded. Or do I still have to
if you
specify
do
the
that,
target?
then there is no like Java side of things at all. So everything is directly going through Python to Rust, and through the Python binding. Yeah.
And in your talking to the use cases, are people using the PySpark version more than they're actually using the Scala version, or are you seeing equivalent of both?
I think what we see is that people, maybe we are talking more to the enterprise users. They are more familiar with this style of loading a jar, and this is also where most of the new features will go, because it just gives us more ability to customize. We have Spark extensions and SQL extension parsers, all those kind of things set up so that we can do whatever new SQL syntax, whatever new features behind this connector more easily. Yeah.
I think there was another question. Oh, I forgot about 𝗟𝗰𝗰𝗲, who's asking, what about comparison with 𝗦𝗽? So when you showed that particular slide that had namespaces and then you actually had compute engines, is 𝗦𝗽 also on the map to support that? I thought I saw 𝗦𝗽 in there somewhere.
I mean, 𝗦𝗽 is another table format, so that's kind of parallel to Lance, I think. Did I misunderstand the question?
No, I think he just 𝗟𝗰𝗰𝗲 is probably asking, is there a 𝗦𝗽? Can I actually specify namespace 𝗦𝗽 as opposed to namespace Unity Catalog or namespace Polaris or Glue? I'm assuming that's what it is.
I see.
Go ahead.
Yeah. Then going back to my original question, I think 𝗦𝗽 is not a catalog, right? 𝗦𝗽 is
a table format.
So I don't think that situation really exists. Unless I think because 𝗦𝗽 have mostly using Hive Metastore, so the Hive Metastore should be the way to go if you want to store 𝗦𝗽 data and Lance data in the same catalog.
Now you had in your fragments, you use the term fragments a lot when the executor executing the particular fragment. There's a little slide. There's a little arrow. Yeah, on the right hand side, you can actually see the fragment consists of the data file, and you actually have a deletion file. What is the deletion file, and what's purpose does it actually serve? Would people get confused that as deletion vectors? I mean, there's no comparison.
That's exactly deletion vector. Yeah.
Oh, that's what it is. Okay, all right.
Yes,
Maybe we should call it deletion vector file.
Yeah, it's just different terminologies in different systems.
Okay, so it is deletion vectors then. All right.
Yeah, and it's a bit more customized to Lance because of the row address, all those kind of things. Yeah, but conceptually, it's the same as deletion vector.
In your the hierarchy of all the stack that makes up the entire LanceDB and LanceDB Cloud, if I was using the open source version of Lance, how would I migrate, say, from using my LanceDB on the local host and now actually want to use LanceDB on the cloud? What is the migration? Will my code from Open or SDK migrate without any code changes, or what's the migration path in that? So I'm starting with Lance format and Lance SDK as open source using LanceDB, and now I actually want to move it to LanceDB Cloud Enterprise. What would be my migration path there, or what would it entail?
Yeah, that's a good question. I think the last line probably explain that better. So it's exactly from the code perspective, nothing really changes, and for users on the cloud enterprise, at that point, LanceDB just becomes a client to talk to it, and all the code doesn't really need to be changed at all. Yeah. And for the existing data, I think there's a difference between cloud enterprise at this moment, because for cloud, people kind of start fresh. So you directly you open a new project. That's the term. You open a new project, and then you create new tables in the project. And for enterprise, you can actually directly mount whatever your lake with it. So you don't even need to do any data migrations.
Yeah, but yeah, there's no data migration because the format is consistent between both the open source and the other one. questions about. Can we actually go back to the slide that actually shows the executors where the term fragmentation is used? So what's the difference between fragments and Spark partitions?
Actually, fragments kind of maps to Spark partitions,
Mm-hmm. Mm-hmm.
and I think we are trying to make it more fine-grained. As I said, that we are moving towards even slicing within the fragment, so that
Mm-hmm. Mm-hmm.
so that it can be more evenly distributed as Spark partitions. But today, it's actually directly mapping to that.
Yeah. So when I do Spark read table, some LanceDB that has multimodal data and all the other associated data frame APIs. So I get back a data frame, and then I say, data frame partition X. Does that actually partition based on the fragmentation?
Correct. Yes.
Okay. Okay. So the fragmentation is just another added version of the partition. So you just add some other metadata and the deletion files, all that, in order to do that partition. So what you actually have on the executor is the equivalent of a partition that each and every CPU or each and every core uses that particular fragment, right? At that
Right.
point, the fragment is equivalent to a partition. Is that correct, or I'm off the mark?
I think mostly correct. Well, one thing I'd like to
Mm.
point out is that unlike most of the other formats, I would say that Lance doesn't have the partition concept, and we kind of intentionally not providing that
Mhm.
because I think we want to move away from the idea of hard partitioning, and
Mhm.
we want to move towards similar to Delta Lake, liquid clustering kind of situation that we only let users define cluster keys, and the data is kind of liquidly dynamically clustered in that sense, instead of having hard boundaries that are drawn uh, and drawn to the data. Yeah.
Mhm. And last question for my part, before we actually close, because we are coming to the hour. How do you, in your one of the slides where you're actually you're creating a table of the Lance particular format, and you're inserting value using the DDL language, but what you actually showed were sort of the data that actually is either ASCII or the supported format. How would you actually how would you insert an image, or how would you insert a video? Would that be something that is like an embedded already, or is it binary format? How would I do an insert in here if I actually had a video?
Yeah. You just insert that as binary.
You just insert as binary, right? So you
Yes.
actually have a binary format that just takes that, and then it knows whether it's a
Yeah,
video or.
and going back to the encoding, so Lance will encode that in the specific blob encoding mechanism, so that it is efficient for later access.
Okay. I think we are on the hour. I think we answered a lot of questions, and you were quite comprehensive in your discussion and you answering the questions. So thank you all for joining us from all around the different parts of the world. Thank you, Carly, for making all the magic work. And thank you, Jack, for the wonderful presentation and all the Q&A. Hoping to see you sometime next month for the both October meetup and also for the October Spark meetup.